Can you hear me? This is not working. Oh, please. Good afternoon. Thank you very much for coming. We're really excited to be here. It's always a pleasure to be in a crowd where people are passionate about the things that you are passionate about. I'm Ido Green, and I'm developer advocate.
I'm Danny Hermes, a developer programs engineer, and I work on the cloud.
Right, and I'm the client guy that will speak about Chrome and HTML5. Today we're going to talk about three quite amazing technologies that keep changing in a rapid pace. We'll speak about mobile, about the web, mobile web, and about the cloud. And we thought to tell a story that will take you through the process that we went. We're building a mobile web app and using and utilizing Google Cloud endpoints as our backend. So let's first just start with a nice little demo that just will show you a macro view of what we did. So you can see this app, and first and foremost, I'll just sign in, because we do want to handle our users and have the amazing photo that I will save under my user, and then is his, and etc. We are here on the normal network, so please, if you are with us,
stop using the internet.
Yeah, it will help us a lot. So I'm accepting. I have this. When it will finish loading.
It's fine. Just click accept.
Yeah, I did.
Demo
so
gods smile.
Yeah, it's demo gods. So basically what we're going here, it's the regular process of what you'll do with you sign in with Google Plus button. And after we're accepting it, it's need to confirm and send us the token back. We'll be able to see the app itself. And basically what it will do, it will fetch all the photos that we have stored in our cloud. Now, the app itself is built on top of few layers, and what we thought would be wise is just to share with you some of the best practices that we encapsulate and baked into the app itself. So the app itself will work when finally we'll end the shake. It will work offline completely. So like any native app that you are accustomed to, this app needs just the beginning to do this call to the server, get all the assets, get the skeleton, and let you work with the app even when you don't have connection or when you have flaky connections. So one of the most important features that we are able to achieve here is that the performance will be much better. We'll have 60 frames per second. The app will be really responsive. Everything will work fast. And the user, of course, satisfaction will be higher. So apparently, our network here is not allowing us to do too much. So basically, I'll try. Maybe we'll switch to
Let's
this.
do it from the desktop. Let's just pretend like we're on mobile. Sadly.
Yeah. So this is our app. And you have here a status button that just will confirm to us when we are offline and online. So you'll be able to see it with us. And I already signed in, so I could do it real quick again, just so you'll see that all the process is working. So I'm accepting. The sign-in button is vanished. And now I'm in the app. I have here my photos. And of course, I can attach and create new photo. So one of the beautiful things here is that when I'm taking a new photo, here it will just open the file chooser and will fetch the photo as you saw. But on the mobile device, it will actually go to the camera itself and allow me to capture and speak with the camera directly. And we'll see that we have lots of device APIs today that are baked into the web platform and allow you to do quite amazing stuff when being closer to the metal. So here I have this photo. I'll give it a title, a description, and I'll save it. One of the things that you saw, it's immediately saved it, and then we got another confirmation that it sent it to the cloud. So basically, we are able here, and here it was quite fast, but if this was working, you could see that we have some lags. But the beauty of it is that we are confirming to the client that the action was done. Our user doesn't really need to be worried about it, and it worked much faster. Now, the photo is here. I'll pull out the network cable, and as you saw, it becoming offline. And I can do the same operation again. So I'm adding a photo. Let's add a new one. Give it a name. And save it. Now we're getting confirmation just that it's saved locally. And since we don't have any connection with the cloud, we'll save it. We'll put it in a queue. And later on, when we do have a connection, and let's just hook it up and see what happened, it will know how to sync it with the cloud and actually enable us to see it from different devices. So if it was working, we could have seen it here and here on different screens. And actually, you could see that we're doing the best with the real estate that the screen itself is letting us. So we passed the demo. Maybe we'll move on. So cloud and client. So let's just have a little role game here. I'm the client guy, as you mentioned, so my answer will be no. We don't need any server, we just need it once to get all the assets, and then we are happy campers. But before we do that, let's just define to ourselves what we see in a modern web application, and it could be web, it could be mobile, it could be both of them. One of the things that we saw, that all of them got one goal, and they're trying to give the user to achieve their goal with the highest efficiency as possible. So they are very focused, very contained. We see more and more code that is flowing to the client side, and that's why we see a flourishing in all the MV star frameworks. Basically, we're talking about clear separation between our data and our views. We just want to be able to maintain our app, especially when they're growing quite fast. Offline first, so like Eric Schmidt coined the term mobile first, we now try to term and work with offline first methodology. So the app will work everywhere, in any case, and it's true that we are in a web browser and we are online most of the time, but even in cases where we are on in a submarine or airplane or flaky connections, we still be able to do the most with our app. Like you saw, the most crucial functionality to take a photo is back there. Device aware, you know that we have now browsers as an open technology on handheld devices, tablets, laptops, desktops, and TVs. So screen size of 2-inch up to, 100-inch, and you should do the best with the real estate that the device itself lets you. Pref matters. It's a hashtag that we're using through all Chrome channels, and we just want to emphasize the importance of making the app work fast. We all know that users love the app to be responsive and snappy, and everything should work as fast as possible. So cloud and server. So if I'm playing the role, and please take my things with a grain of salt here, I could say, hey, we have quite a lot of amazing HTML5 APIs that allow us to save the skeleton of the app in the app cache, to use local storage or file API or IndexedDB or any other methodology that will let us save state and data on the client side. So basically, we are quite happy just to be on the client. We want to minimize the interactions. Why? Because network is quite slow, specifically on some networks, like we have here a perfect example. And we want this one connection, and that's it. So really to do the most from any and each connection that we are making. The way to do it is just to pretend that there is no connection and then to build the sync layer. Because as you saw, to save things locally, to save things offline quite easy, the logic or the magic is in this sync layer that does the right things in the right moment. And the code here is just a really simple API to know where we are offline or when we are online.
So when asked the question to me, are the cloud and the client friends? Well, of course they are. Maybe the tablet and the network in this room aren't friends, but the cloud and the client are definitely friends. So I'm a resounding yes on this one. So when you're building a modern application, you're obviously thinking about your client first, whether it's the mobile web or a native application. But they have to rely on the cloud. Users are used to holding a phone, which they treat as a data center. They send off queries to very large organizations that are doing very intense things across the network, and they actually expect this from your applications. So being able to offload computation is actually a big deal. When you have lots of users, you want a single source of truth for data. You want to be able to store it somewhere other than the client, right? And of course, as we saw here, we have the tablet which won't work and the desktop which is connected to Ethernet and just fine. So you have some users signing in from more than one place. So you actually need the cloud, a server, to have this one source of truth. So he's saying we have to minimize interactions, we have to be offline. Well, that's actually a good thing. It's not abandoning the cloud, it's informing the way that we actually think about the cloud. So does anyone remember DRY? Don't repeat yourself? We hear this all the time. When we're writing code, obviously, don't write the same thing twice. Write functions, write classes, whatever. But when we're talking about the network, it's just as important not to repeat yourself. Because in the situation where you don't have lots of network, you can actually rely on the things that you already know, rely on the conversations that you've already had, and use these nice HTML5 technologies to actually keep this data around. So we have to actually get the most out of each and every interaction and lick the bowl clean like a good boy or girl. So now I want to talk a bit about the tools we use to build this application. I'd love to demo it at some point.
Yeah, totally.
So we actually use a good chunk of the Google Cloud Platform, which is what I work on. And I just want to talk about some tools that we use to help our friends. So if it wasn't already clear, The cloud and the client are friends, so we do need a server. But who wants to run a server? It's hard, right? Let's go shopping. No. So running a server is hard, and we want to make it easy. So some of the things that are solved problems that are hard but not worth solving are things like traffic spikes, communicating with your client and your server, actually doing authentication, trying to figure out how to make payloads efficient. Like I said, these are all solved problems, and these are things you shouldn't be thinking about when building an application. So we want to be the easy button in as many places as we can, and we want to push this down extra hard. So the biggest technology that we run on is Google App Engine. Google App Engine, for those who don't know, is a platform as a service which allows you to write code in your language of choice, here Java, Go, Python, and as Urs announced earlier today, PHP as well, but actually get to use Google's infrastructure to scale up and scale down based on your traffic. And in addition, you also get to use App Engine's NoSQL data store to store and interact with data the same way Google services do. On top of Google App Engine, we're using Google Cloud Endpoints, which essentially allows you to write an API that looks like a Google API. More about this later. What does that mean, a Google API? So all modern Google APIs have something called a discovery document. And it's a giant bit of JSON. You don't have to actually see what's on this slide. But what this discovery document does, it fully specifies everything the API can do. So it's a language to actually describe what payloads should look like, what methods are available, what kind of auth is needed, you name it, it describes how the API behaves. Okay, Danny, so what? I don't care. It's JSON. Cool. Well, so what? By having a single document to describe all APIs, we have client libraries in lots and lots of different languages that actually understand discovery, no matter which API it is. And so if we bring a new API online, these libraries out of the box work with that API. Okay, sweet. So with Google Cloud Endpoints, you can write your own API that looks like a Google API, and this giant tool chain is already at your disposal. So now you can think about features instead of thinking about how in the world am I going to send my data back and forth. And the last piece of the puzzle that we use, it's a library that I wrote, so it's definitely my favorite piece. It's called Endpoints Proto Data Store. And this is a way for us on the Python runtime of Google App Engine to have a way for our data and our interface to be the same. So I have this sample class up here, bank account, which says, OK, we've got an owner, which is a string, and a balance, which is a float property. So in my bank account, I have leet dollars, right? But my data through the client looks exactly like the structure that I'm defining on the server. And this, again, data is the most important thing in our application. I keep saying API, API, API. Well, that I in API stands for interface. And when we're writing applications, we care about getting data to the server and just moving away from that step. All we really want to do is send what we know and just move on from there. And so by using this library, we're actually able to do that. So enough about the tools we did use. Let's talk about how we use them.
So we'll take it from the client. And as you saw before, and actually now it's all here because some time passed, so we have it locally here as well. But here, the most important aspect is when we open DevTools, we could see literally that we have all the metadata under local storage. So the metadata on each and every photo is there. And then we used AppCache and File API to save the photo themselves. When we're speaking about the application itself, so we touch about it, but we want the skeleton of the app already in our disposal. So one interaction, and we're getting the HTML, JavaScript, CSS of our app. We could download some assets, like some images and MP3 files if you want. And once we do that, the app is full functional. And from that moment, basically, we're using this sync layer to speak with the server when we want this one source of truth to broadcast all the information to all the different devices that will consume and use this application. Photos, we love photos, and that's why we shift our app around them. For photos, we have quite a lot of abilities to save them. In our case, we use files. So like any other platform, you could really use files under the browser. And in our case, HTML5 File API is really nice to work with Filer.js that Eric Biderman wrote, and it's open source on GitHub. And basically, it lets you work with files like you're working in files on Linux. One of the things that we did here, and that's another tip, is that we choose the right tool to the job. So when we want to save metadata, local storage is perfect key value API. When we want to store the images, we want to store binary data, so it will be much more efficient to render the DOM with them, and we don't need this base64 in and out each time. So that's why we choose the file API with the local storage to do the best in both worlds. When we're going and speaking about the world out there, it's usually not white and black. It's usually the golden path between them, and it's a complex world. We have a wide range of devices with browsers, with versions, and we want to support as many, of course. And in our case, one of the things that we choose is this abstraction layer. In our case, it's Launcher, but there are plenty of other libraries that are out there that basically mask the low-level APIs that you are going to use, and it will do the best things with the capabilities that your user browsers is letting you do. So if it's quite an old browser and it just supports, let's say, local storage, it will do that, or web storage. If it have NoSQL, the new IndexedDB there, it will use it. If you need WebSQL on other platform, it will let you do that as well. And it's really nice because in your data layer, you could just commit this save method, and under the scene, it will do the right things with it.
So we actually can do this demo because it doesn't require the network.
Right. So let's switch.
So this is the mobile device.
And you can see now that we got all the photos from before and even the one that I took on the machine itself.
Let me get this up. There we go. And I have here
This one.
the Chrome inspector open for this application, and we can actually see all these assets. So if we blow them away, goodbye, 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 and go back to the application, force a reload, we still have the application, but none of the data is there, and we really don't have a connection to make this happen. So it's really completely happening locally. So it's a wonderful thing that we actually get to demo something.
Lucky us.
So that was how it works offline. And I promise, though that button was green, that really was offline. But let's talk about online, how we're actually talking to our server when we are talking to our server, as infrequently as that may be. So first, that red button, which would have worked great, is very simple to add if you want to add authorization to your application. It's really a tiny bit of HTML, just a button, with a sign-in callback to actually respond to OAuth. To respond from the response of whether or not sign-in was successful or not. So this is another thing which we don't have to do, easy button. So how about discovery? How is discovery helping us with actually calling our API? So in this first code snippet up above, we see gapi.client.load, and then there's an API name and an API version. And this is how we're actually loading the client library for a specific API, in this case, the URL shortener API. And once we've done that, the gapi.client object now has a URL shortener object, which it owns, which knows how to do everything in calling that API, which is specified in discovery. And through the library, we just pass in our payload, and from there we get an object which has an execute method, and that execute method will take a callback, and that callback handles the response. It's very simple, and it's based on the discovery document for that API. So with Google Cloud Endpoints, this is already at our disposal. So in the same fashion, we specify our API name and version to gapi.client.load, but we also need to specify an API route, because we can't host our APIs on googleapis.com if we're not Google, right? And then to actually call the API, it's the exact same thing. gapi.client, API name, the resource, then the method, and you got it. It's the exact same thing. So I got this.
Yep.
So what happened to minimizing interactions? So there was actually a bad thing in there which goes against these things we were saying before. gapi.client.load actually uses a network call every time we want to talk to a new API. So if we are in these conditions where we don't have a great network connection, wasting one request could make a difference between actually retrieving a photo and making a user's experience better or not. So to get the most out of it, we have to tweak this a little bit and get our hands dirty, but not too dirty. if you were to pop open the Chrome DevTools and check out the network for a typical request, you would see a giant waterfall with a bunch of RPCs down the left. And one of those RPCs really isn't too complex. It's a standard path based on where your application lives. And then the actual payload takes a method, name, so here picturesque photo list when we want to list photos, and then the actual payload as params. So constructing one of these, not so difficult, but we wanted to make things easier, right? So never fear. GAPI actually provides us a way to do this without wasting that network request on GAPI client load. So we can actually create the RPC request by hand using GAPI client and call it in the exact same fashion by passing a callback to execute. So it's OK. We can still use it. And this is how we're calling offline. So now that we know how to call offline, let's actually see how we're doing this, not in the abstract, but in the applied sense in our application.
So we all know and we spoke about the separation between our data and the views. And here, when we are taking a photo, one of the most important aspects is that today in modern browsers, you're putting this one line, and basically you're getting the ability to go to the camera itself, and in some cases to the file system that you have on the device, and to choose the camera. So you don't need any other acts or any other libraries in order to support this close nature to the metals of the device itself. When we're coming in, to do it in our own application, what we have here in store is our own data layer, and we have the URL callbacks just to make sure that we'll be able to respond to the things that we make in the configuration of it. But then the beauty is that we have the save click, and basically we just need to focus on that. Our add photo method is masking us what we'll do beneath it in the sync layer. So for us now as developers that using this library, we just want to save the photo. We don't care about if it's locally, if it's in the cloud, whatever. We just know that it will be saved, and then the callback will return and will let us know what happened with it. So we'll communicate it to the view itself.
So on the server, when that add photo request comes through, in the same way we defined a bank account using Endpoint's proto data store, we define a photo with the same data that we expect to send in our interface. And with that, there's a nice bit of sugar. There's a decorator provided, photo.method, which allows us to decorate a method which will expect to actually receive a native photo object based on the data from the request. So here, we could do some things to validate the request after it comes in, but essentially all we really want to do is store it. So we call photo.put to save that in the App Engine data store.
And in the client, when we basically use this separation between our data and our views, what we did is just listening to the online navigator, and you could see quite nicely here what's happening. So let's see this piece of code and walk you through it. Basically, we have the task object that know how to handle our calls to the API itself, and we have some payloads and some metadata on our photos. And when we're going and we want to active a new task, basically we'll see if our user is logged in, and here we'll know. In case it doesn't log in, because we had some problems like in our demo, we'll go to this special queue and just put it, and we'll wait until it will be authenticated and log into our app. If in the case that it is logged in, we just need to check with Navigator Online if we are online or offline, and that in case we are online, we just want to call the task itself and do the best in terms of going local storage or moving it to the cloud. And if it's not online for some reason or we got some flaky connections, we'll just add it to this queue of offline tasks that will run over and over to make sure when we have connection to just take those tasks and send them to the server. The beauty here is that we always take the photo and immediately save it locally, but then when we have connection, we'll sync it to the server itself.
No, is there a... Here, he's got it. All right, so sorry about that. We're actually going to try to demo something. They've got some hardware which will let us get Ethernet into that tablet. So after we create a photo, there's really only one other thing we want to do for this application, which is getting photos potentially from other devices that we have saved for our account. So we're actually going to, this is the point where the server doing the expensive things comes into place. But in doing those expensive things, we have to keep something in mind. Minimize interactions if it wasn't clear already. So what are some things that we're doing? We're loading photos in the order that the server learned about them. And so by doing this, we actually have a timestamp, which is sort of the latest date that our client knows that it talked to the server. And of course, in the same way we implemented the sync layer with create, when it's time to actually talk to the API, if we're not online, we're not signed in, we defer it into some kind of task. Back to the slides, please.
Yeah.
So on the client,
what we do here is basically quite simple. We're getting the local photos first and getting a remote callback. And now that we got all the local photos first, we're getting some metadata with them, and one of the most important aspects is the last update. So we'll call the server with this attribute and making sure that we're just getting the delta of the photos that we don't have locally. And that will, of course, improve the performance and basically will reduce the time and the time around that we are spending just to get all the data back. As you can see in the client, it's quite simple. The not problematic but challenging aspect is on the server side. So let's see how it's done there.
So on the server, we're trying to make our queries more intelligent and make our server work harder so that our clients don't have to. So what we're actually going to be doing is creating an index for sort of more complex interactions. So by default, the App Engine NoSQL data store will create an index for every property that you have unless you tell it not to. So if you want to know every photo that I own with title of foo, it can do it for you out of the box. But if you wanted something more complex, like a composite of some properties, like here we see owner and updated, you would have to specify that in an index.yaml file. It's just a specification when you deploy your application. So this actually makes it a little more expensive every time we have to write our entity to the data store when we're saving the data that we've received from our clients. We also have to create a log in an index to actually reference later when we're doing these queries. But the advantage is when our client makes the request, it's way faster. So to actually provide this through our interface, the library endpoints proto data store actually provides us with some extra sugar other than properties to be persisted. We also have a property called endpoints alias property, as you see here, which allows us to have fields which are only a part of the interface and never get stored anywhere. And so for us to actually let the client ask us, hey, I know about everything up until 20 minutes ago. Can you give me everything since 20 minutes ago? We have to give them a way to send 20 minutes ago, right? So we have an endpoints alias property, and the real work here is happening in a setter. So in that setter, there's really three things that happen. So the first thing, we take the value from the request, we try to turn it from a string to a native Python datetime object. If we can't do it, we raise what's called an endpoints.bad request exception. And for those familiar with HTTP status codes, that tells the client, hey, here's a 400, you sent me bad data, send me good data or don't talk to me, right? And of course, if we did get good data, then we take the query associated with the request, and we are able to add a filter, which here says photo.updated greater than or equal to last updated. So what this does, it takes our data and says we only want the things which have been updated since, for example, 20 minutes ago, whatever timestamp came in through the request. And finally, when we're actually serving this request, in the same way we got a photo.method decorator, we have a photo.query method decorator, which allows us to interact directly with a data store query instead of directly with the data, the photo from the request. And so we want to order that query by when it was updated. And by doing this, if a user has to actually page through a result set, they will get them in the order from oldest to newest. And so, for example, if you drop your connection while you're paging through a result set, you'll actually be able to say, well, it used to be that I knew about everything up until 20 minutes ago. Now I know about everything up until 10 minutes ago, and so I don't have to waste that query for the time in between. So that was everything that we would have showed in the demo. Some other things that we would have liked to have done, and which we will be adding to the open source code for this application. One would be sharing. So we actually did implement this before, and we were able to create an access control list or an ACL for every photo and allow users with Google Plus share intents to actually have a native Google Plus share button and share their photos with other users. And it would, again, be based on OAuth and fairly easy. In addition, we were downscoping the photos, shrinking them so they would fit in the Google App Engine data store. There are many pieces of the Google Cloud Platform that address storage. And so Google Cloud Storage or the Google App Engine Blob Store are probably a better place for large and high-quality photos rather than the data store, which in the same way that local storage was a good place to actually store metadata, while the local file system was a good place to store photos, we have the data store as a good place for metadata and a nice bucket-type system like cloud storage, which is a good place for photos.
Whew. Yeah, take a deep breath. So we tried to tell you a story and communicate some important aspect that we found compelling. One is that Google App Engine, and specifically Google Cloud Endpoint, is a powerful service that you might want to check out in your next API, service, or product that you are building. Always think about performance and try to minimize the connections and optimize each and every connection that you're doing to the server. Use abstractions layer and do clear separation between your data and the views. It will be much more maintainable code. And as you all know, you're reading code much more than you're writing it. So you do want the shortest possible clear code in your app. Leverage modern browser features. So we have actually on the mobile browsers quite a lot of features. And a site like caniuse.com could reveal to you all the new APIs that mobile browsers are supporting, and we have great adoptions in that field, so just use them. We have some really nice talks today, tomorrow, and on Friday that are addressing it, and we highly encourage you to check them out. There are a few options here. Danny choose his favorite, I choose mine, but feel free to check them out. Some compelling stories about how to do interesting things in the cloud and on the mobile web. Thank you very much for your time. We do have like 7 minutes, and we'll be more than happy to try and answer your questions.
In theory, we could do the demo.
Right. If you have any questions, just please come to the mic.
Hi.
Howdy.
I've been using cloud endpoints for some time.
Cool.
And it's really, really cool. One of the things that is probably out of the scope of this conference, access control. I mean,
Yes.
it's kind of a huge beast to handle sometimes. So I'd love to see like elegant ways of handling access control.
Sure,
and
sure. I don't know that there's a question there, but I will address sort of the general concept. So with access controls, we're essentially, every user, especially when you're doing Google Plus sign-in, you get access to their Google Plus ID via the scopes that they allow. And so there's sort of a global ID for accounts. And so what we were allowing the data store to actually have just a list of account IDs associated with every photo. And then in addition to that, to make queries for somebody else's stuff that I was allowed to see, we would also, on our user objects, where we were storing our created user accounts, we would keep a list of all the other users that had shared stuff with them. And so by doing so, as sort of a first-order implementation, we were able to actually to utilize the data store and queries from App Engine to make it appear fast. But as far as something native, there's not anything that I know of.
Elaborate on the Google Plus sign-in plus endpoints integration, because for Plus login, you need to request a different scope than for endpoints, right? The
Sure.
user email scope versus the Plus
Yep.
login scope.
So the question was, he wanted us to elaborate on how you can use endpoints and G Plus sign-in at the same time. What actually happens with endpoints for typical OAuth is you need the email scope and sort of nothing else, and G Plus sign-in requires the user info profile scope, but you can actually combine the two. So you have a token which has both scopes on it, and either ID tokens or bearer tokens can be used with endpoints. And so if you actually send a bearer token, it will still check out that it has the email scope. It's only in the ID token case where that will fail, since you don't just have the email scope.
Yes, please.
On the client side, in this example, it looked like all the data was kind of dynamic. I was wondering if you have any guidance around, what would traditionally be the static part of the pages that are then filled in with the dynamic data, with the idea that I want to cache this and have it available, somewhat offline.
Yeah, so actually, we couldn't show it, but in our demo, we had the structure of the app itself, which wasn't dynamic at all. So we had all the assets with us. All the nice button and the footer and the header are actually being fetched in the first call. And from that on, once we have the skeleton of the app, it could be a background image, it could be some music file if you like. Once we have all that, then we're fetching everything dynamically. And it's actually a phenomenon that we see in lots of different apps, native and mobile webs, where you have this skeleton and then the data itself is being retrieving. All the apps that containing some long list of things, it could be a mail, it could be a social app, it could be a photo app. It's usually the skeleton just like we did, and then all the photos there. I didn't mention it, but the app itself is live in that URL, and you are more than happy to check it when you have connection and see that it's work for real. Yes, please.
Cool. I maybe have 2 questions for you guys. Is endpoint still considered experimental?
It's considered preview.
Preview?
The language around that in cloud platform has recently changed. We have a product manager here who could probably talk your ear off about it, but I know a fair amount. So preview essentially is our way of saying it's not completely general availability yet, which is our generic term for like no labels at all other than just use it, right?
Right.
But we're committed to it. We're committed to improving it, and we're actively working on it very quickly.
So that's my second big question. I'm the developer of the Ferris web framework
Cool.
for App Engine, and I'm planning on integrating cloud endpoints with that so that Ferris can
Sorry,
automatically.
what framework did you say?
Ferris. Ferris by
Ferris, like
yeah.
Ferris wheel?
Like Ferris Bueller.
Okay, that works too.
Yeah,
Same
and
Ferris.
just to be lazy. It's kind of similar to Flask and Django in a way,
Okay.
but specifically for App Engine. So we're planning on integrating cloud endpoints
Yep.
into Ferris, so you can kind of share the same code between the two.
Okay.
So the big question there is, how much more is the API going to change from this point?
Yeah, I can't answer a question like that.
You can't answer a question like that, but
yeah.
let's. Okay, cool. Yeah, so I was just wondering how much we can expect to you. New features is great, but I mean, like, just kind of the core. Is the core kind of solid? Do you guys feel?
So Cloud Endpoints is actually more than just an App Engine feature.
Right.
Because it uses a shared infrastructure that all of Google's APIs use as well.
Right.
And so there's a fair amount of, like, Discovery itself is a specification, and there's also a back-end configuration which allows us to register with that shared API service and say, this is what I look like, this is the kind of things that I want you to send me, this is the kind of things that I'll give back to you, and other related things like auth. So this is an active conversation which we have a lot. So I'm happy to talk more about it after. But
Thanks. It's great so far. Proto-RPC and
Cool.
everything involved in that looks great so far.
okay,
Thank you guys.
cool.
Awesome.
OK, thank you very much. Bye-bye. Almost.
Yeah.